The concentration of a substance is very important in our daily lives. Household items like rubbing alcohol, mouthwash, bleach, and various cleaning products can have various concentrations of their active ingredients. When we buy products, we sometimes take the concentration of the active ingredient into consideration, such as when buying a skin-treating astringent. It is either 1% or 2% salicylic acid, so we make our choice based on how sensitive our skin is. Chemists also have to be aware of the concentration of solutions they use during laboratory procedures. One of the ways concentration is expressed is through molality. Molality, symbolized by a small m, is the number of moles of solute per kilograms of solvent. The unit of molality is therefore expressed in moles per kilogram. The formula for molality is m equals moles of solute over kilograms of solvent. In problem solving involving molality, we sometimes need to use additional formulas to get to the final answer. One formula we need to be aware of is the formula for density, which is d equals m over v, where d is density, m is mass, and v is volume. Let's use the density triangle as another way to remember. You can use the placement of the letters in the triangle to know how to find the value for any of the variables. Density equals mass over volume, mass equals density times volume, and volume equals mass over density. In molality, the unit is in moles of solute per kilogram of solvent. There are times when we are given the mass of the solvent in grams. Since we know that 1 kilogram equals 1,000 grams, we can convert the number of grams into kilograms. Just multiply the number of grams, x, by 1 kilogram over 1,000 grams. Sometimes we are given the number of grams of solute. Molality is the moles of solute per kilogram of solvent. To convert the number of grams of solute to moles of solute, we follow the equation moles of solute equals mass of solute over molar mass solute. To find the molar mass, we need to count the number of atoms for each element and get the sum of all the atomic masses of the atoms in the chemical compound. We can get these from the periodic table. The molar mass equals the sum of the number of atoms times the atomic mass of atoms. Let's go over a few examples of common problems encountered when we want to find the molality of a substance. Example 1. What is the molality of a solution containing 0.75 moles of sodium hydroxide in 500 milliliters of water? The density of water is 1 gram per milliliter. We can find the solution by plugging into the equation of mass equals density times volume equals 1 gram per milliliter times 500 milliliters. Therefore, mass equals 500 grams. Convert the grams to kilograms by multiplying 500 grams times 1 kilogram over 1,000 grams. This equals 0.5 kilograms of water. Molality equals moles per kilogram, so the molality is 0.75 moles sodium hydroxide over 0.5 kilograms water, which equals 1.5 m, or moles per kilogram. The molality of the solution has 1.5 moles of sodium hydroxide per kilogram of water. Let's try a second example. What is the molality of a solution containing 85 grams of sodium hydroxide in 1 kilogram of water? Well, to determine the number of moles of solute, we need to first find the molar mass of our solute, sodium hydroxide. Sodium has 23 grams per mole, oxygen has 16 grams per mole, and hydrogen has 1 gram per mole. Adding these together, we get 40. So the molar mass of sodium hydroxide is 40 grams per mole. Now, we need to calculate the number of moles of our solute. The moles of sodium hydroxide equals the mass in grams over the molar mass. We were given the mass in the question as 85 grams. So plug in 85 grams over 40 grams per mole, and you get 2.125 moles of sodium hydroxide. Now we can calculate the molality as m equals 2.125 moles sodium hydroxide over 1 kilogram water, which is still 2.125 moles. So the molality of the solution has 2.125 moles of sodium hydroxide per kilogram of water. One last example problem. A solution with a molality of 1.5 moles of hydrochloride contains 0.25 moles of hydrochloride. What is the mass of solvent present? We can make a triangle out of the molality formula and come up with the formula for determining mass. M equals moles per kilogram. So in our triangle, we'll have mole at the top representing the number of moles, m at the bottom left representing molality, and kilograms at the bottom right representing the mass of the solvent in kilograms. Now we can more easily see that molality equals molality over mass in kilograms. The number of moles is molality times mass in kilograms, and mass in kilograms equals the number of moles over molality. Therefore, the mass of our solvent equals 0.25 moles of hydrochloride over a molality of 1.5 moles, which equals 0.17 kilograms. The mass of the solvent is 0.17 kilograms. There are different ways to express the concentration of a solution, and one way is to express it in terms of molality. Molality, M, is the number of moles of solute per kilogram of solvent. The unit for molality is expressed as M, or moles per kilogram. In problem solving of molality, it's important to make sure that necessary steps are taken to ensure that all units are correct. Multiple steps may need to be taken, and different formulas may need to be used to solve the problem correctly.